Good morning. I'm Ed Evans, and today's October 30th, a Sunday. I want to share an important video, robotically read, about an article from NASA Earth Observatory, and it covers information about Arctic amplification and the importance of albedo. Well, there's more than albedo involved in Arctic amplification, presumably, and that is the role of thunderstorms in the equator region, the equator of the Earth. And there, because of tropical thunderstorms, heat rises way up into the atmosphere and makes its way to the Arctic region, where life becomes warmer. And thereby, equator thunderstorms add, odd as it seems, to Arctic amplification. There are links below to Wikipedia, to the NASA site I mentioned, Earth Observatory. There's a few robot-read questions here, as well as a tiny bit of vocabulary. Remember, James Kroll, the Scottish scientist who was also a janitor, and he's the guy that gets credit for bringing albedo to our attention as an important role in warming the Earth and keeping the Earth from warming, because albedo means to reflect sunlight in terms of climate science. And that's an important concept to remember and share for other people. This is why the Arctic's important.
Arctic Amplification, NASA's Earth Observatory. January 1st, 2000 to December 31st, 2009. As far back as 1896, the Swedish scientist Svante Arrhenius hypothesized that changes in the concentration of carbon dioxide in Earth's atmosphere could alter surface temperatures. He also suggested that changes would be especially large at high latitudes. Arrhenius didn't get every detail right, but his argument has proven to be pretty sound. Since the mid-20th century, average global temperatures have warmed about 0.6 degrees Celsius 1.1 degrees Fahrenheit, but the warming has not occurred equally everywhere. Temperatures have increased about twice as fast in the Arctic as in the mid-latitudes, a phenomenon known as Arctic amplification. The map above shows global temperature anomalies for 2000 to 2009. It does not depict absolute temperature, but rather how much warmer or colder a region is compared to the norm for that region from 1951 to 1980. Global temperatures from 2000 to 2009 were on average about 0.6 degrees Celsius higher than they were from 1951 to 1980. The Arctic, however, was about 2 degrees Celsius warmer. Why are temperatures warming faster in the Arctic than the rest of the world? The loss of sea ice is one of the most cited reasons. When bright and reflective ice melts, it gives way to a darker ocean. This amplifies the warming trend because the ocean surface absorbs more heat from the sun than the surface of snow and ice. In more technical terms, losing sea ice reduces Earth's albedo. The lower the albedo, the more a surface absorbs heat from sunlight rather than reflecting it back to space. However, other factors contribute as well, explained Anthony Del Genio, a climatologist from NASA's Goddard Institute for Space Studies. Thunderstorms, for instance, are much more likely to occur in the tropics than the higher latitudes. The storms transport heat from the surface to higher levels of the atmosphere, where global wind patterns sweep it toward higher latitudes. The abundance of thunderstorms creates a near-constant flow of heat away from the tropics, a process that dampens warming near the equator and contributes to Arctic amplification. To read more about how climate change and Arctic amplification may be affecting storms, read the feature In a Warming World, Storms May Be Fewer but Stronger. Credit, NASA image by Robert Simon, based on GISS surface temperature analysis data, including ship and buoy data from the Hadley Center. Caption by Adam Boyland.